All right, so in this video, we're going to put everything together and do a one sample z-test for population proportion. So to perform this significance test, we are going to state a hypothesis, check the conditions, calculate the standardized test statistic and the p-value, and then make a conclusion in context. Now, we're going to use the same four-step process that we've been using to organize our work. So state, plan, do, and conclude are the four steps. You want to state the hypothesis and parameters at and significance level at the setup. Excuse me. In your plan step, you want to identify the appropriate inference method that you're going to be using and check the conditions. Now notice checking the conditions comes before the calculations and the conclusions, and also identifying which method you're using is important to do first because that tells you which conditions to check. Okay. And then you proceed to the do step if the conditions are met, where you calculate the test statistic and p-value. And then in step 4, you make your conclusion about the hypothesis in the context of our problem there. Okay. So the appropriate inference method for testing a claim about a population proportion is called a one sample z-test for a proportion. And it is a significance test of the null hypothesis that a population proportion is equal to the specified value. Now, little AP exam tip, you can use your calculator to carry out the mechanics of the test on the exam. But again, there's a risk involved if you just give calculator answers with no work and one or more of your values are incorrect, you probably won't get credit for the do step. If you opt for the only calculator only method, make sure you complete the other 3 steps, the state, plan, and conclude, and report the standardized test statistic and p-value in the do step as well. All right, so let's look at an example here. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. The potato chip producer has just received a truckload of potatoes from the supplier. A supervisor selects a random sample of 500 potatoes from the truck, and inspection reveals 47 of the potatoes have blemishes. So we want to know, is there convincing evidence at the 0.1 significance level that more than 8% of the potatoes in the shipment have blemishes? Well, here we go. Uh, let's do the 4-step process. So state, we want to test. So your null, so proportion is 0.08, and the alternative, now remember, he said more than, so it's going to be greater than 0.08. All right, and then we say where P equals the proportion of all potatoes in this shipment with blemishes using, I can't do the alpha, so it's A equals 0.10. Okay. And then we're going to do the plan step right here. Okay, so we got to check each of the conditions. So random, again, you can't just put a check. It was a random sample of 500 potatoes from the shipment. 10%. Again, they didn't tell us the population of potatoes, but we know it's from a big truck, so it's reasonable to assume that 500 is less than 10% of all potatoes in the shipment. Okay, and then the large counts. All right, for this, I'm just going to write it out. Um, so we would have 500. So this is NP. And remember, we use the null proportion. That's equal to 40. That's greater than or equal to 10. And um, N times 1 minus P, which is 0.92, is equal to 460. Remember, you're going to use the null proportions to determine the large count condition. Since both of these are greater than 10, we can scoot on to the do step where we calculate p hat, which was 47 out of 500, which is 0.094. And then we're going to calculate our z value. Okay. So z is equal to 0.094 minus 0.08 divided by, now remember, we're going to use the null proportion, not the sample proportion, because we're trying to determine the p-value of getting this sample result if the null were true. We're not trying to create a confidence interval. So it's going to be 0.08 times 0.092 all over 500, which equals 1.154. Okay. Now, the next thing we're going to do is just do a rough sketch. We go 0, 1, 2, 3, 1, 2, 3 of the standard normal curve. Our p-value of 1.154 is right here. And so we're looking for greater than, so we want the area to the right of that value there on the table. So we can do this one of two ways. We can use technology. If we use technology, um, the p-value is going to be 0.1243. And if we use table A, the p-value is 1 minus 0.8749. Because remember, you have to go to 1.154 on the table. The probability associated with that is 0.8749, but that's a left-sided or a less than probability, so you have to subtract that from 1, which would give us 0.1251. Okay, and then finally, in the conclude step, you want to make a conclusion based on your p-value with respect to the significance level in context of the problem. So we would say because the p-value of 0.1243 is greater than alpha equals 0.10, we fail to reject the null. That's first sentence. Remember, you got to do a two-sentence structure. There is not convincing evidence that the proportion of all potatoes in this shipment with blemishes is greater than 0.08. All right. So this example reminds us why significance tests are important. The sample proportion of blemished potatoes, which was 47 out of 500, was gave us a proportion of 0.094. That result gives us some evidence against the null of 0.08 and in favor of the alternative, which because it's greater than 0.08. To see whether or not an outcome is likely or unlikely to occur by chance alone when the null is true, we had to carry out this significance test. The p-value ends up telling us here, okay, that a sample proportion this large or larger would occur in about 12.5% of all random samples of 500 potatoes if the null were true. So while the probability is kind of small, we can't rule out sampling variability, especially since our significance level was 0.1. Okay, so now let's look at this AP tip right here. When a significance test leads to a fail to reject null decision, as in this example, make sure to interpret the results as we don't have convincing evidence for the alternative in context, whatever it is like we did here. So notice we said there is not convincing evidence. Saying anything that sounds like you believe the null or is or might be true will lead to a loss of credit. So, for example, it would be wrong to conclude there is convincing evidence that the population proportion of blemished potatoes is 0.8. Okay. So, what happens when the data don't support the alternative? Suppose the supervisor had inspected a random sample of 500 potatoes and found 33 with blemishes. That would yield a sample result of 0.066. And so that sample doesn't give any evidence to support the alternative hypothesis. Okay, if we went through and calculated the z-score and the p-value, this graph here shows that this proportion is a little bit less than the null. So 0.08 was the null. So it's below the mean of the standard normal curve. And since we were doing a one-tailed, right-tailed test, the p-value would be to the right of that, which is 0.8757. So and remember, the p-value is the probability of getting a z-statistic that large or larger in the direction specified by the alternative. Okay, so as a result, we'd fail to reject the null. But if we did a full significance test, but we don't even need to because this value is less than the null, and the alternative hypothesis was looking for something that is greater than. So always check to see whether the data give convincing evidence against the null, or excuse me, give some evidence against the null in the direction specified by the alternative before you start doing some calculations. All right, guys, that's it for this one. Hope that was helpful to you.